Hello everyone, welcome back to 3 Deviations. So in today's video, I want to talk some more about sine and cosine integration. So we are going to be again looking at where we have some integral of sine to some power, let's call that m of x, times cosine to the power of n of x dx. And we really don't know how to solve this other than the formulas I talked about earlier. So we're going to be applying those formulas today to a plethora of different examples. I like that word, plethora. We're gonna be applying it to, yes, a plethora of different examples, and we're gonna try to exploit all of the different cases that we looked into in the last video. So without further ado, let's get started with that. So here's our first example. I want us to integrate sine to the 6th of x times cosine to the 5th of x dx. So immediately we can see that we have an even power on sine and an odd power on cosine. Okay, so let's think this through. We are going to want to strip off a power of cosine because that's the odd power. We're going to want to make that something that's an even power. So this brings us, so this is going to give us the integral of sine to the 6th of x times cosine to the 4th of x times cosine of x dx. And right, what we do after this is we take that and we multiply, and we kind of factor that in. So we've got a cosine squared in the inside. And if we remember our trig Pythagorean identity, that says that the sine squared of x plus the cosine squared of x is equal to 1. So we can rewrite this so that the cosine squared of x is really equal to 1 minus the sine squared of x. So what we do is we plug this in here, and that's going to give us a really nice substitution. So what we do is we take this, we take the integral of sine to the 6th of x times 1 minus sine squared of x squared times cosine of x dx. Now we're ready to make a substitution. We've got all these sines up in here. We've got one cosine hanging off the end here. So what we do is we take these sines and we make that our u for a substitution, a change of variables. And then we make our du, that derivative, so that becomes cosine of x dx. So now we're ready to make our substitution. We've got all of our parameters all set up. And now this is going to give us the integral of u to the 6th times 1 minus u squared, quantity squared, du. Now this is great because this is literally just some algebra. We don't really even need to make a u substitution. We can just do a mental u substitution, which I hope that some of you are doing on some of these easier integrals that we come across. But that's something really good because now this is just some arithmetic and we're going to be able to deal with that quite easily. So let's do that. So we're going to do that arithmetic. What we need to do is we need to FOIL this guy out. I don't know, maybe some Algebra 1 nightmares coming back. But I'm sure you've done that already in your calculus courses. This gives us the integral of u to the 6th times 1 minus 2u squared plus u to the 4th du. And we multiply everything by u to the 6th, and that gives us u to the 6th minus 2u to the 8th plus u to the 10th du. All of that's integrated. And now all that we need to do is apply the reverse power rule. So that gives us 1/7 u to the 7th minus 2/9 u to the 9th plus 1/11 u to the 11th. Now we got to plug in all of those signs back in there, and that's going to give us 1/7 sine to the 7th of x minus 2/9 sine to the 9th of x plus 1/11 sine to the 11th of x plus c. And that's all there is to it. That was quite a lengthy example, I would say. This last bit, at least, was a mouthful for me. Yeah. That is one of our examples. So now let's move on to another. We're not always going to have a product of sine and cosine. Sometimes we might just have a lone cosine, but this is still going to apply. So we have an odd power of cosine, but actually what we can do is, well, cosine, so well let's say cosine is equal to some variable. Let's call this variable psi. So if cosine is equal to psi, then we have psi cubed is equal to psi squared times psi. We can do that. So now let's set the integral of cosine to the cubed of x dx equal to the integral of cosine squared of x times the cosine of x dx. Now we did this similar kind of power stripping as we did back in the last example, and now again we're ready to make that substitution. So that gives us the integral of 1 minus sine squared of x times cosine of x dx. Again, now we're perfectly capable of making this u substitution, setting u equal to sine of x and du equal to cosine of x dx. With that change of variables in place, we can now set this equal to the integral of 1 minus u squared du, which is obviously trivial. That should become second nature to us by now. And this is equal to u minus 1/3 u cubed. And again, making that substitution in, that gives us sine of x minus 1/3 sine to the third power of x plus c. That was a good example. I really like that one. It kind of shows you that even though you might feel like this is hopeless, you've still got a choice. Okay, now let's look at a final example. So I want to look at the example of sine to the square root of x cosine squared of x dx. Now, of course, we can recognize this because our powers are both even. So we've got even power here, we've got even power here. So what we are going to need to do is we're going to need to apply those weird kind of double angle formulas that we looked at earlier in that reduction video, and that we also looked at in the last video. So let's apply this. This is going to give us the integral of 1/2 1 minus cosine 2x times 1/2 1 plus cosine 2x dx. We take out the 1/4 constant, multiply, FOIL everything out. It gives us 1 minus cosine squared of 2x dx. Okay, now we're going to need to apply that identity again. This is going to give us 1/4 times the integral of 1 minus 1/2 times 1 plus cosine of 4x dx, which is equal to 1/4 times x minus 1/2 x plus 1/8 sine of 4x plus c. I know that was quite a mouthful. I'll give you some time to write this down. And as always, please remember, feel free to pause the video and do these problems on your own, and you'll be able to do the problems on your own, and maybe that will be better for your studying. While we're at some nuts and bolts here, if you want, we have a playlist from I think early 2021 called the Daily Integral, and in that playlist we went through a lot of integrals in James Stewart's calculus book, and we did integration by parts, trigonometric substitution, which will come next, partial fractions, which is still pretty far out there, use substitution, obviously, integration by parts, and then some of these trig integrals. So if you're having trouble, we've done quite a lot of those, I think on the order of about 120 of them. I recommend that you check those out if you're having trouble, and those will also give you some solutions. But I still like giving some solutions in our videos like this one here. Something else, we've got our website up and running, so if you want to check out blog posts of some of the integrals that we look at, or some general opinions on math and physics, please feel free to go check that out. Well, thank you very much for watching today's video, and we look forward to seeing you in the next one. We're going to be looking at tangent and secant integrals, and we'll follow that up with an example video and then some cotangent and cosecant. All right, well, thank you for watching, and we'll see you in the next one.